So I asked my team to say, since we are doing edge computing with WebAssembly, can you guys find me some use cases? So the guys tried a lot of things, and one day they come to say that we find a solution that involves hardware. I said, hardware, that's not that interesting, let's keep looking. And 2 weeks later, they come back to me and said, we have sold a couple hundred of those hardware for $100,000, for tens of thousands of dollars. That really got my attention. What did you sell? Who did you sell to? And so this is a device that I want to demonstrate and talk about today. It's a device that's for local AI that's sold to developers. So I thought this may be more interesting to this audience than I come here and talk about why WebAssembly is not web and not assembly. So this is a device. So, I'm gonna go to the next slide. Okay. So first of all, I really wanted to do a live demo, and Eva asked me to do a live demo. However, as soon as I got here, I checked the latency of the network and find it's impossible because, for voice application, we need round trip within one second, at least 2-3 seconds. But the network round trip to AWS, because most of my servers are in the US, to AWS, or even in the ones in Europe, is about 2 seconds, right? So instead, I went back to my hotel room and did some optimization for the network, and then recorded a live demo. Recorded not a live demo, but a demo at the, is there? Can I turn on the speaker? Okay.
Yeah. I think there's a. Or maybe we should just talk over it.
Okay.
Yeah.
Well, maybe I can turn on this. Yeah. Okay. Yeah. I think I can do it. Yeah. So. Hi. Where are you? Can you hear that?
Yeah. Hi. I'm Echokit, currently attending the Docker Captain Summit here in Istanbul.
Nice. Tell me something interesting about Istanbul.
Did you know that Istanbul's staggering 80,000 cubic meters of water?
It skipped a word because of the network.
336 marble columns turned the underground chamber into a surreal lantern-lit museum that's still a must-see for visitors today.
Interesting. I thought its metro is also interesting. So, let me. You get the idea. The whole demo is about less than 2 minutes, right? So basically, I built an AI agent and injected with knowledge about the Docker Captain Summit and Istanbul, and then I can ask about questions, have it recommend me places. With the MPCP server integration, I can also ask me to order tickets for me, right? So this is the device that's. It looks like a development board. So, so the idea is developer have it, and they would be able to build their own applications and then embed this into some other form factor they want, like like a toy, something like that. Talk to your kids or learn English, whatever, right? So. I think I have 2 minutes left, so I want to give you a very quick peek in terms of how this was built, right? So one of the things that I think most people have heard about is real-time APIs. OpenAI has one, Gemini has one, so those are what we call end-to-end models, meaning that's, the model itself takes audio, video as input, and it generates audio and video as output as well. The good thing about those models is they are very fast, so you can have real-time telephone conversations with those models. However, the problem is that it's not very customizable because every step in the way, you can't easily inject context or knowledge into that. It's very difficult to do voice cloning, and there are a lot of things that are very difficult to do with that approach. So the approach we took is a fully open source approach, and everything from the front end to the back end is all written in Rust. There are no Python involved. So although we do use libtorch, but we just use Rust wrapper over the C library. We have there's because everything has to run very tightly together, so there's no Python involved. So you can see this flowchart. Basically, the if you see my demo, the computer on the background is my laptop. So my device gets on the Wi-Fi network of my laptop, and then it goes on to the internet. So it's communicated with the laptop. The laptop runs what we call Echokit server. It has a model. It has a model in it called VID. It detects the turns. So the model determines when I'm stopped speaking. When I ask a question, you need to respond, right? So it first goes to voice to text, and then it goes to large language model. With large language model, you can have MCP servers and tools, meaning that you can do web search, you can do a lot of, you can control the lights. If you have those smart light switches and things like that, you can ask it to turn off the lights, open the curtain, things like that. So you can do this at this step, and then it's so all the Istanbul knowledge and things like that are stored in the database that are accessible from the MCP server. And once you have the MCP, once you have the text return, it goes out and say, I want to turn that into voice, TTS, and then goes back to here. This whole process has to be done within 1 to 2 seconds. And then so that with the network delay, you're going to see, you're going to get the response within 3 seconds, right? So a lot of, that's why we use Rust, right? A lot of the optimization was done to make sure all this, everything is streaming and everything is connected through streaming. Instead of waiting for one API call to finish, we start another API call building the KV cache while the voice to text is still generating text, right? So there's a lot of things that are going on here. So and everything here is all open source. If you're interested, you can go look at. So with all this, why are we even here? Why are we even talk about this in the Docker captains meeting? The reason is because Docker truly made it easy to do, because for this Echokit server, like I talked about, there's Rust, there's libtorch, there's an AI model called VAD, voice activity detection. All this has a lot of dependencies. It has very specific dependency about libc and things like that. So really the best way to run it is just to put it in a Docker container so that you have no other dependencies to measure, right? And then on the model side, we can use, several people have talked about Docker Model Runner. We can use Docker Model Runner running locally on my Mac. That's so that the LLM call does not go to the US and then generate some response and come back, right? So we can have the fully local run large language model. I really look forward to Docker Model Runner to support the other models as well. However, at this moment, we have to go to the other API services to do that. And then, of course, with the Docker Model Runner and the MCP server and tools, that we can go and select, from any of the MCP servers that are available. For instance, in this case, we connected with DuckDuckGo so that it can search internet about, what's going on in Istanbul and, things like that. So, yeah, that'll be my talk. Thank you.